आइए हम सुने विज्ञान की अनकही कहानियां।
Join this scientist from the WADIA Institute of Himalayan Geology as he digs into critical metals, the invisible heroes powering your smartphone, electric car, and clean energy future, ensuring tech advancements touch every life.
Myself, Dr. DrCPerumalsamy. Currently, I am working as a scientist at the WADIA Institute of Himalayan Geology. If you talk about my previous research, geochemical and isotope studies on clastic sediments in the southwestern coast of India. Using that, I go to using heavy minerals. I found out source nature and provenance studies. Currently, I am working on some granitites and mafic enclave in the active continental margin, where the subduction of oceanic slab and then subsequently the collision between India-Eurasian plates caused the formation of granitites and mafic enclaves. If you study granitites and then enclave, it gives some idea about the source of subducting oceanic slab as well as the collision between India-Eurasian what is the scenario behind the India and Eurasia collision plates. Sometimes the continental crust it is the main source for critical and economic metals. Wherever the subduction zone, you can find a lot of critical metals like zinc, copper, molybdenum, vanadium, nickel, copper. So if you study about the granitites, so you can tell about you can get some mineral reserve with this one. Earlier I initially studied about some plastic sediments, as well as I compared with nearby Kindle and source rock. Using that, using the geochemistry, here I have taken Ladakh patholith. Using that, I found out the using geochemical and isotope parameter, I found out the source nature of Ladakh patholith as well as the geotectonic evolution of Ladakh patholith. My future, I will find out some sediments. It is sediments associated with the mineral reserve in the continental margin. That is now India performing some by some other countries by students exchange program. Some MOU only they are doing now. DST they are approaching many collaboration like now it's India, US also now, particularly lithium exploration now collaborate with India, Australia also, now India, US also. Mainly the critical minerals. The now many research going on this one. Yes, sir. Many private industries they are collaborated with the Germany and Africa also. They are coming and here also they are visiting in India. They are here also they are some technique they are learning from Germany also. By in this case they are doing collaboration and they explore many research service one. Currently I published three research papers. One is sediments. Then mainly I am handling ICPMS. ICPMS. I presently two methodology paper going on. Already 3 paper published to this one. So now I currently mainly focus on instrument research. In this research, mainly I will collect some granite and pegmatite. You see, I will collect this granite and pegmatite. I will do geochemical studies. From this, I can found the transition metals. If you see, I will quantify I will quantify the transition metals. Using that one, I can bound some mineral reserve. Right? Geochemical studies usually using for geochemical studies we need a ICPMS. ICPMS only we can measure this one. They quantify the elements by using ICPMS only. Inductively coupled plasma mass spectrometer. it can measure, it capable of measure the whatever the elements presence in the rock in the very ppm level. So using that one, usually the trace elements, it is occurring naturally in the ppm level, including rare earth elements. Nowadays, rare earth elements very important for many advanced industries. They are mainly focusing rare earth and critical minerals and metals. This research mainly going on. So.
This podcast series on STEM popularization is supported and catalyzed by National Council of Science and Technology, Communication, Government of India. Produced by Media for Community Foundation. Technical support is given by Soumya Mishra.